Good morning to all. Today I will explain about my topic biocomputing future of molecular level computing. So next introduction. Yeah, use biological derived molecules such as DNA and OR proteins to perform the digital or real computations. The development of biocomputers has been made possible by the expanding new science of nanobiotechnology. The term nanobiotechnology can be defined in multiple ways. In a more general sense, nanobiotechnology can be defined as any type of technology that uses both nanoscale materials. For example, having the characteristics dimensions of 1 to 100 nanometers and biological basic materials. A more restrictive definition views nanobiotechnology more specifically as the design and engineering of proteins that can then be assembled into larger functional structures. The implementation of nanobiotechnology as defined in this narrow sense provides scientists with the ability to engineer to biomolecular systems like so that they interact in a fashion that can ultimately result in the computational functionality of a computer. Next, scientific background. Biocomputers use biologically derived materials to perform computational functions. A biocomputer consists of a pathway or series of metabolic pathways involving biological materials that are engineered to behave in a certain manner based upon conditions of the system. The resulting pathway of reactions that takes place constitutes an output, which is based on the engineering design of the biocomputer and can be interpreted as a form of computational analysis. Three distinguished types of biocomputers include biochemical computers, biomechanical computers, and bioelectronic computers. Next, bioelectronic computers. The biocomputers can also be constructed in order to perform electronic computing. Again, like both biomechanical and biochemical computers, computations are performed by interrupting a specific output that is based upon the initial set of conditions that serve as input. In bioelectronic computers, the measured output is the nature of the electrical conductivity that is observed in the bioelectronic computer. This output comprises like the specifically designed biomolecules that conduct electricity in highly specific manners based upon the initial conditions that serve as the input of the bioelectronic system. Network based computers. In network based biocomputation, self propelled biological agents such as molecular motor, proteins, or bacteria explore a microscopic network that encodes a mathematical problem of interest. The parts of the agents through the network are added, their final positions represent the potential the solutions of the problem. For instance, in the system described by Neoelectric mobile molecular motor filaments are the detected of the exist of a network, encoding the complete problem subset sum. All exist the filaments represent correct solutions to the algorithm. Next, exist not visited or non-solutions. The motility proteins are either actin and myosin or kinesin and microtubules. And then the is added to active filaments or microtubes or propelled through the channels, thus exploring the network. The energy conversion from or chemical energy like ATP to mechanical energy is highly efficient when compared with example electronic computing. So the computer in addition to begin massive parallel also uses orders of magnitude less energy per computation. So thank you.
ಸ್ಟಾಪ್ ಮಾಡಿರ್ಲಿಲ್ಲ.